So first we need to know why these three temperature we are studied for knowing the basic semiconductor physics. What is absolute temperature? In absolute temperature, we need to know no semiconductor operates in absolute temperature. Now in room temperature, all semiconductor properties will be measured in room temperature. But in absolute temperature, this is the lowest. But in ambient temperature, the 17 degrees Celsius, in ambient temperature, the all communication system and antenna and transceiver signal to noise ratio can be calculated in this. So about this, we need to know about the three temperatures. Now the next topic is volt equivalent of temperature or thermal voltage. Volt equivalent of temperature, or we can know this as a thermal voltage. The symbol of this, that is V suffix T. Now the formula of thermal voltage is V suffix T equals to Kelvin bar into T temperature divided by Q, where T is the temperature in Kelvin and Q is the magnitude of charge plus 1.6 into 10 to the power minus 19 coulomb, that is electronic charge. And you need to know about the what is K bar. K bar is the Boltzmann constant. You know this value is 1.38 into 10 to the power minus 23 joule per degree Kelvin. So what is thermal voltage? Thermal voltage equals to volt equivalent of temperature. So if you calculate the if you put the temperature and the value of charge and is the Boltzmann constant, then you can get the value of the equivalent voltage corresponding to the temperature. So if we calculate, that is if T equals to 0 Kelvin, let's suppose, and Vt, obviously Vt becomes multiplied by 0, that is all are 0, so Vt becomes 0. And if T equals to 300 Kelvin, that is the room temperature. In room temperature, we get the value of Vt equals to 26 millivolt. This is need to be remembered. That is the room temperature. What is the value of thermal voltage? Now, how this is calculated as 26 millivolt? Let's discuss later. So by this equation, we get one conclusion. That is Vt, that is the thermal voltage, is proportional to the temperature. Now, here you can note down that we can calculate, that is K bar by T by Q, K bar by Q, that is Boltzmann constant by charge, equals to 1 by 11600. Now you can directly put into, if T equals to 300 Kelvin, then Vt equals to 300 by 11600. This is, we get 0.025 something volt. So this is 26 millivolt. By this, we can calculate the Vt in room temperature. Now, for a large variation in temperature, that is, if temperature is high, then we get the minute value, that is low variation in thermal voltage. Variation, that means variation. This is not, that means it varies. That means if increase the temperature, we get, if we increase the temperature or about, we can conclude that the properties of semiconductor will change. So if we increase the temperature or decrease the temperature, we can get the different value, that is the semiconductor properties will change. So the next chapter, that is the next topic is electron volt. This is most important topic in the semiconductor physics, that is electron volt. Electron volt. So this is we suffix as EV. We can measure, this is the unit we has there. Now this is, what is this? What is electron volt? This is the practical unit of energy. Practical unit of energy. Why this we require in this semiconductor physics? We know joule, that is joule is very big unit. Joule is very big unit. Joule. So we know that joule is very a big unit to measure the energy. But in semiconductor, we require a very small unit, because this is the part of the electrons and small electrons, and so this will require a small energy unit. So for need to measure about the small unit, we produce the electron volt, that is EV. What is the value of EV? Now the relation of EV and joule equals to 1 EV equals to 1.6 into 10 to the power minus 19 joule. So this is the relation between the electron volt and the joule. Now in the semiconductor, we know that there are two bands. One is conduction band and another one is valence band. So this is the gap. Now what is the meaning of this gap? This gap is known as the energy gap. The next topic is energy gap. Now what is energy gap? The gap between two bands, that is conduction band and valence band, is known as energy gap. This is symbolized as E suffix G. So this is one type of forbidden energy gap. Sometimes what is meaning by forbidden? The forbidden meaning as the no electron can stay here. That means all time jumping, that is on valence band to conduction band to valence band. So this is an forbidden energy gap. So there are two types of semiconductor we can make, that is germanium, that is Gi, and one is silicon. Now let's describe the value of the energy gap at 0 Kelvin, that is energy gap value at 0 Kelvin of germanium. The germanium value is 0.785 electron volt, and for silicon the value is 1.21 electron volt. And the energy gap at 300 Kelvin, that is in the room temperature, the value of germanium is 0.72 electron volt, and for silicon it is 1.1 electron volt. You need to remember of these values, that is in ambient temperature and room temperatures, and for the numerical problems we have solved in later. Now the relation between energy gap and temperature is inversely proportional to the temperature. The energy gap is high, the temperature will decrease. In the energy gap will decreases, the temperature will increases. So the relation is inversely proportional. Now let us discuss how to calculate energy gap of a semiconductor at any given temperature. At any given temperature, how to calculate this value, how to calculate. So let us discuss. Now the formula how to calculate the energy gap in a given temperature is the energy gap in any given temperature equals to energy gap at 0 Kelvin minus beta naught into T. This is the formula, and the unit is electron volt. So what is the formula? Energy gap at any temperature equals to energy gap at 0 Kelvin minus beta naught into T. What is beta naught? Beta naught is a material constant. Is the material constant. The unit is electron volt per degree Kelvin. Now for germanium. The value of Eg naught, we know that 0.785, and the beta value is 2.33 into 10 to the power minus 4. If we put the value into this, we can get any temperature, the value according to the for germanium semiconductor. And for silicon, the energy gap value at 0 Kelvin equals to 1.21, and the beta value equals to 3.6 into 10 to the power minus 4. So easily can you calculate the energy gap value, as you know, this is remembering part, and we can calculate at any temperature. For silicon semiconductor, we get the energy gap at any temperature by putting the temperature value here. So now let us in the next video we'll discuss about the electric field intensity.